Welcome, everybody. We're going to be working on Module 5 today. We have a new topic and really a collection of topics, and I say that with a little tongue-in-cheek humor there. This is our agenda for the day. We're going to look at arrays, which is an important data construct inside of C Sharp, algorithms that you can use to work with arrays, and then we're going to look at the concept of collections and what that means. But I think it's kind of interesting to maybe even look at this photograph here as it comes up on screen, because what we're looking at here is basically a storage array, right? This is a server rack, and each one of those things sitting vertically in the server space is basically a hard drive inserted into like some sort of a NAS or a SAN or whatever the network construct is that they're using. But notice how like all the hard drives in here are in this one machine. So this one machine holds all these hard drives. And if you look really carefully, right above each drive, there's a number, right? And the number starts with 0, right? So even in the hardware world, they start counting at 0. And so in other words, if I'm referring to, like, let's say an issue with drive 0, it's the first one. And there's a whole array of drives in this one server rack. A lot of correlations to the material we're about to cover. Um, so that kind of is a nice little overview of getting into an array, because basically what an array is, it's a variable structure that allows you to hold multiple values of basically the same data type. All right. And basically you use square brackets to denote the contents are an array. So look at the declaration here. We have basically we're still declaring a data type of int. So in other words, the array is going to hold integers, but the square brackets tell us it's an array, meaning it's a variable that's going to hold more than one value. It will be numbers, as the name will designate. There's nothing being put in this initially, right? Compare that to the traditional approach of declaring a variable, where we just say int, whatever the data type is, and the name, right? So this creates one spot to hold something. This can create many spots to hold something, right? And then you have to ask yourself, how many? Well, okay, well, that depends, frankly. When you are creating an array and you're doing it in this fashion, and this is basically, we're creating an object in memory. Whenever you see the new keyword, that implies and we're going to learn all this terminology next week, we're instantiating a new object. And what is the object? The object is an array called numbers that holds 6 values. So this number here is how we declare the size of the array, meaning it's named numbers, just like a regular variable, but it's got 6 holding spots. So it can hold 6 things inside of it, right? Some important, oh gosh, I rearranged the slides there. We didn't want to do that. Boy, I really rearranged the slides, didn't I? All right, well, not too bad. All right, sorry about that. Kind of threw me off a little bit. All right, so when we're actually creating an array, it doesn't really matter what data type goes into it. So like any of the data types that we learned that are valid data types can be used. So it doesn't have to be just an integer. You can see all these other numeric formats. So there's floats and characters and longs and doubles, and strings too also can be used in an array. You can see all the various declarations here, and you can see that each one of them has a size declaration. So temperatures would hold 100 values. This one would hold 41. This one would hold 50, and this one would hold 1200. And I know that kind of seems crazy huge, but not really, right? If you have 1200 values to contend with, that's the right size. But the fact that you can do that with one variable name is kind of powerful for sure, right? So the declaration, once again, the size declarator, as they formally call it, it has to be non-negative. So I can't make an array that's got a negative amount of holding spots. Pretty logical, right? it's basically got to be above zero. It's got to be at least one, right? Um, it can be either a literal or a variable. So in other words, when you put the size declaration in, you don't necessarily have to hard code a number here. And a real common usage for constants, by the way, so this is the example, is that often people will declare a constant as a regular number that they can inject here. And then wherever this appears in their code, obviously, they can change all the locations at once by just changing this one value. But this is a really common usage of a constant, by the way. Ironically, I was teaching my Python class over at the other school last night, and we were talking about the exact same concept, which I find kind of like weird parallels that way. All right, but in this case, right, so we're creating 100 temperature positions in this array that holds floating point numbers. All right. Now, interesting things about working with arrays in this language, right? And I was just mentioning Python, which Python is super hyper flexible when you're working with this kind of stuff. C# is not. So if you guys already know Python, caution treading the waters here a little bit. So here's some of the really important notes. You have to declare the size when you're creating it, right? Once the size is set, you can't change it. Okay, that's kind of a big deal, actually, right? So you got to plan ahead. You got to know how big it's going to be, or anticipate, or maybe make it a little bit larger than you think it needs to be, just in case, right? Also, once you set the data type, you can't change the data type. So I can't like go flipping the array from holding integers to holding strings or holding doubles or something like that. Just can't do it, right? Once you actually create the array, you can kind of conceptualize it like this. Think of it as a collection of little boxes. Each one of those boxes has an index value or a sub number or a subscript, as some people will call it, that allow you to access that memory location. So for example, if I have an array called my numbers, I have position 0, 1, 2, 3, 4, 5, which is 6 total values that I can store stuff in. And they're discrete storage locations like a regular variable is. So in other words, all those little boxes kind of perform like their own separate variables. How you access and put stuff in them and take them out is different though, because of that subscript, basically. So you got to like kind of accommodate for that when you're working with it. So for example, when you want to pull out the value of 20 from index position 0, this is the syntax we use. We use square brackets. The square brackets indicate which sub number we're contending with, right? And the value. So for example, if I use this statement here, this would assign the value of 20 to this spot in the array. If I put 30 in position 3, that goes in the 4th position, right? Because 1, 2, 3, 4, 0, 1, 2, 3, that's the 4th position. And I want you to notice also that when we created this array, if we don't put stuff in the array, what is the default value? We're going to talk about that too. That's kind of strange, right? In fact, I think that's the next slide if I'm seeing it correctly. Some people will use this, nomenclature basically when they're referring to arrays. I will be real frank, I don't. I usually say index position, whatever. That's how I do it. But I have heard a lot of programmers use this kind of speak, which is, my numbers sub 0. My numbers sub 0 is 20, or my numbers sub 3 is 30, right? So that's just how some people say it. All right. So yeah, there's a question. Where did the zeros come from? Well, when you create it and you don't put something in right away, C# will pre-initialize your array. So in other words, it's putting something in on purpose in advance so that it's there. It's kind of like, think of it like a balloon's not a balloon until you put some air in it. All right. So we're kind of putting some air in each one of the boxes just so something is in there. It does depend on what kind of data type you're using. So if you're working with numbers, like any numeric format, you create the array and it's empty. Every spot's holding a 0. If you do characters, it puts in the character code, which is basically 0 for characters, false for Booleans, and then all other objects, so that would be like strings or other complex data types, they'll just put in a value of null. And having a value of null inside of an array, and I want you to notate this, null is different than nothing, right? Null is the state of nothingness. Nothing is just nothing. I know it goes back to like the something is everything, everything is nothing, whatever. All right, so we get into philosophy and stuff there, but this is basically what's stored in there is a null value. So like if you try to extract the value, you get this null thing. All right, so when we're doing the declaration, and this is kind of a weird way to create an object, but this is really the full and correct declaration. You declare int with square brackets or whatever your data type, give it a name, set up the assignment statement, and then you're using the new keyword, which implies that we're creating a new object. And then this will tell us what type and how big, right? And that's a complete statement. So it's named, we're saying it's an array, we're saying how big it's in, how big it is, right? Now, interestingly, as it says here, the subscripts refer to each element 0 through x minus 1. And this is kind of like a weird kind of thing. So x being basically the size of the array, but the index value goes from 0 to 1 minus whatever the size of the array is. So this is an array of size 6. See, 1, 2, 3, 4, 5, 6. But the numbers are 0 through 5. So the biggest number is the size of the array minus 1. That's kind of the point. All right, moving on. Here's a silly little exercise, but I think we're going to try doing this. I think this is a good one to kind of get you kind of ramped up a little bit to how it works. And so the ask is create a program that asks for the donation amount for 3 philanthropists without using a loop. Ask for 3 amounts and then print them out. Print out the total amount. So that's kind of what they're asking us to do here. All right, so let's bring up Visual Studio. I'm going to go ahead and create a new project. If you guys want to code along, that's probably smart. Good practice. And we're doing a console app here. Just kind of going with our defaults. Store the stuff where you normally store it, and I'll do the same. And we're selecting that folder, and I think I'm going to call this mod 5. What do we call these? Try it's or something like that. Yeah, try it out. Try it. Oh, how about that? All right, and then I'm going to take the defaults on these next couple of screens, and we should have a fresh program here in a moment. All right, let's get rid of that code. Let's go back and look at the instructions again. I already forgot them, right? Create a program that asks for the donation amount for 3 philanthropists without a loop, ask for 3 amounts, then print them out. So we're going to gather the information and then print out the information. So just a little bit of practice, and then we can, worry about the totaling and stuff afterwards. But let's start first with the data structure itself. So from what I saw from that screen, they're putting in dollar values, which has decimal points, right? So we need to have an array of doubles, I think is a good place to start. And I'm typing on the wrong screen. All right, here we go. All right, so the data type is going to be double. We are building an array, so square bracket. Now notice how intuitive this is, but we're going to call it donations, and I'm going to say new double, and it doesn't know what size to put in, but how many are we supposed to get? 3, right? So I'm just hard code the number 3. All right. The other thing that I noticed is they want us to keep a total. All right, well, you know what? If I'm going to total doubles, I probably want to total it in a double variable, and I'm going to preset that to 0. Right. I want you to notice something really interesting here. what Visual Studio is doing right now, it's like, hey, you've got an array. You must want to iterate or loop through that array. So it intuitively is like setting up a for loop as the next maneuver. And this is kind of telling actually, because an array has a repeated structure and loops are really good at repeating things, right? So they often work very, very well together, by the way. All right, but we want to do something a little more basic here. We're going to do a prompt. So here's my prompt. So how much is donated, right? So I'm going to ask that once, and then we're going to read line it. And then, but we want to store that, right? So where are we going to store it? Well, let's go to the donations array. Oops. That's what happens when you don't type it correctly. Right. Right. And notice how it grabs the sub number. So, and what number did it grab first? A 0, which is the first position in the array, right? The counting starts at 0. And what are we putting in there? Well, the read line, basically. So we're going to convert to double, right? Because they're typing in a dollar amount. And then we're going to store it in the first position of the array, which is built to hold doubles. So perfect. We're going to do this 2 more times, right? So that's really simple. That's just a copy paste, right? You're going to spread them apart like this. That's fine. And then I would say, update the numbers so we know that we're looking at something different. And then the second number is not going to go in position 0. That one's going to go in position 1. And then the third one's going to go in position 2. And 0, 1, 2, that's 3 values. That's the size of our array. All right. Now we need to total all these, right? So how are we going to do, well, let's look at the instructions again, because I think we might be missing a piece. Okay, so we're going to prompt how much donated, 1, 2, 3. We got that. Now we're going to put those back up on screen, and then we'll do the totaling. So, all right, let's do the output back to the screen. All right, so here comes the output. Well, I think that's pretty intuitive, right? So we'll do our standard console write line, and let's string interpolate here, and then let's do donation number 1, I think is how they had it, with a colon. And then we'll use our curly brackets, and we'll throw the first position of the array in here. So we're going to say donations, square brackets, 0, first position. And then we want to convert that to currency. So we'll do colon C. And that's it, right? That's the whole statement. And if I have the one statement, well, I have the others. Oh, what did I forget here? Oh yeah, my closing parenthesis. And once again, we're going to update the numbers. So this is going to be number 2. This is going to be number 3. And then these sub numbers need to be adjusted. So index 0, index 1, index 2. 3 values. Right. 3 prompts, 3 outputs. All right. Next, we have to do the total, right? Well, the total variable's already been created. How do we populate total? Well, we can just take the 3 values, right? So we can say donations 0 plus donations. Okay, yes, correct, Visual Studio. Notice how it read my mind. The code I'm typing is so predictable that it guessed it correctly once it got the pattern going. So it's taking all 3 positions and adding them together. So, I mean, really, when you start to think about this, this is a convenient way, if you're working with similar values that you're storing, to put them all into one object and then pull the ones out that you want from that one object, as opposed to having 3 separate variable names. Right? Because if you were dealing with 100 values of the same kind of variables, how would you name those variables? Num1, num2, num3, num4, num5, anyhow. You see why it makes sense to put them all into one object and then use the sub numbers? Yeah, it's very, very logical. All right. Then we just need to output that, right? So I could just grab one of these statements here and put it down here. And then we would just say total. And then we would just output total. All right. And you know what? Let's give it a run, make sure it works. And I don't have the dollar amounts from the other page. I'm just typing in random stuff here. We're going to assume that the math is correct. All right. And I'm just like guesstimating if it's correct. Yeah, that's about correct. Yeah, that looks correct to me. All right, everybody get it to work okay? Okay, great. All right, let's move on then. So that's our first little try it out there, and it's kind of nice to try those actually. All right, let's move on to the next slide here. Next topic here is the fact that when we are working with an array, and I mentioned this before, isn't it interesting that Visual Studio automatically, it's like, hey, you've got an array in there, you must want a loop, right? And very, very common activity, once again, to loop over the contents of an array. One of the things that they kind of point out here is that the subscript can actually be put into a variable, and you can use variable names inside the subscript instead of necessarily hard coding a number. So they ask the question here at the bottom. It says, what do we know that can increment a variable from 0 to 1 to 2, right? And so they can go to the next slide. Well, hey, how about a for loop, right? And a for loop is a really good mechanism for incrementing the subscript. So check it out. They're calling the loop control variable index, right? They're setting it to 0, which is the same starting number as the array starting number. And then as long as the index is less than or equal to 3, which it'll never reach because the highest one is 2, we'll keep incrementing. And then we do whatever this activity is, which is to read line and store it in that position. But notice that the index value, every time the loop will go through, this will increment by 1 automatically, beautifully matching up with the index values in the array. It'll go 0, 1, 2, it won't reach 3, and it'll be out of the loop, right? So a really nice match between loops and the array, especially if you're trying to put in a bunch of content all at one time. So very commonly used together. All right. So now the ask is, how about we modify that program that we just built and use a loop to do, well, probably what part can we repeat? What is the repeating part? Well, prompting the user is the repeating part, and outputting the contents is repeating, right, as well, right? Yeah, both of those are repeating. So let's go back and see if we can, first of all, recognize the repetitions. These are all repeating, right? And this is all repeating, right? That's all right. That's kind of interesting, right? That you can just see that. So let's do this. I'm going to create a little space in the program, and I'm going to borrow code from down here, but I am going to set up my CSS style comment here. And basically I'm going to comment out all that repeating code. So all of those prompts and read lines, and then all of the outputs are just putting them in a comment, right? That way I can still borrow from the code and use it over. But if a for loop works really well to traverse the structure, and I'm just going to type for here, and of course, Visual Studio's suggesting exactly the thing I was going to type. Exactly the thing I was going to type. It's so beautiful. I don't even have to type it, right? But I would set up an I or an index or something like that to basically run the loop, right? And I am going to start at 0. Why? Because it matches up with the sub numbers, basically. And then we're going to run it, not up to the hard-coded 3. I could hard-code a 3 here for the length, but the length, donations length is correct, and then we'll increment one each time. All right, so now we have a loop. What are we putting in there? Well, this will be for the prompts. So we could take this prompt and drop it in there along with the read line. However, instead of hard coding the one, right? Okay, well, first let's switch this to string interpolation. I'm going to put a $sign at the front of it. And then I'm going to come in here and I'm going to put in a set of curly brackets. And what am I going to put inside there? I'm going to say how much donated for the first donation, right? I want to be on the other side of that colon, don't I? Here, let's move that right now so I don't forget. That should be here. So normally I drop I in here, but I really want to go I plus 1 so that it matches up with what we were doing before, which is the number 1, because you know, normal people don't start counting at 0. What's your first donation? Yeah, that's number 1, right? Okay, so that's why we're doing that. Then here, instead of putting in a hard-coded number, we're just going to use the index loop control variable in its spot, and that will dynamically update each time the loop runs. And then we, instead of totaling total down here, I can also make that part of the loop. So I can actually do total plus equals the donation that we currently took in. So notice how that saves us another step, right? How powerful that is. All right. And then we're also going to be asked to output everything. And the output is repetitive as well, right? So let's do this again. And I'm not going to use I equals 0, that even though it's suggesting it, and that would be fine. I'm going to use J, right? Because I already used the I. That's how my brain thinks. And we're going to run it with the same criteria, right? We're going to run it up until the length, not to exceed, and then we're going to increment by 1 each time. And then what are we doing? We're just doing a write line. So we can just take one of these write line statements and modify it so it's more generic. And so instead of saying donation number 1, we're going to say the same thing we did before, J plus 1, right? And then here, instead of saying donations with a hard-coded number, we're just going to use the J. We're going to format it as currency. And, well, we're mostly done, right? So we've captured all of them, done the totaling, done the output. All we really need to display now is just the total, but that can just stay down here at the bottom, right? So let's go ahead and run this and see if it works. Here's the save, and here comes the run. So how much donated? I don't know. I'll just do the same kind of goofy thing I did before. Okay, works exactly the same. But you see the logic here, right? If I was doing an array that was much, much larger, okay, like repeating the statement 3 times, not really a big deal, right? That's not a lot of time saving. But if this number was 333, these 2 loops would save me a significant amount of code on the page, right? I wouldn't have to like copy paste that 333 times, right? And then the other aspect of it is because the structure itself, this array that we've created, has multiple values, right? It lends itself very, very well to working with loops, and this is really the big takeaway there. So that's a very common thing to do, and we'll see plenty of that as we kind of move forward. All right. Here's one of the issues that you start running into with loops, right? The fact that we have an array of a given size, so the top one is of length 6, the bottom one is of length 4, but the numbers start at 0 and end at one number less than what the size is. We always, you know, especially if we're thinking of the size of the array as this X, we always have that offset basically of that 1, you know, it's off by 1. So whenever you're setting up your code to deal with these structures, you need to accommodate for that as the programmer. You got to think about it, because the number one error of working with loops and arrays is understanding where the array ends, and you don't want your loop to run past the end of the array, because something bad happens when you do that, by the way. All right. So here's kind of what happens. The compiler won't necessarily catch that you're out of bounds. So in other words, if I set up the array to be a certain size, and then I set up my code to traverse a size that's bigger, for example, you know, the compiler isn't going to say, hey, you're setting it up and it's too big. It's going to let you do it because it figures you know what you're doing. But if you go over the bounds of the array, right? So in other words, here's an example of this. Instead of it being less than or equal to 3, right? Because we never would reach 3, but with the equal to, we would go 1 beyond the size of this array. And then what happens is we get this error, index out of range exception at runtime. And it won't necessarily highlight in the code window as you're typing it. It's something you see when it's running. So when we say runtime, this is a runtime error, not syntax error that highlights. So we often call these, by the way, off by one errors, right? Because usually when people get it wrong, they're just off by one. They forgot that it starts at 0, or they forgot how long it is, or they put in the equal sign when they shouldn't have put in the equal sign. And this is what it looks like in the console, the output that you get, right? So it says, be careful that your loop starts at 0, not 1, right? So if you're going from 0, right, and ends at x minus 1, not x. Okay, so I think we're just kind of repeating the same thing over and over again, but it is a thing that happens a lot, and that's why it's repeated here as a potential problem, right? And by the way, right, professional programmers screw this up all the time too, right? So like if you're doing it and this happens, you're like, oh, duh, whatever. Okay, then you adjust it. Regular programmers, do it too. So you wouldn't be alone, basically. Common mistake. All right. When we are setting up arrays, we had the way that we saw before where we use the new keyword and we create all the spots. And with that approach, we create an array that's empty. And if we're doing numbers, for example, like this one is, all zeros would go into every spot. There's a different way to do it too. You can actually declare the values going into the array without declaring a size. So for example, notice there we're creating an integer array called days, and then with curly brackets on the outsides, declaring a comma separated list of values. And how many values are we putting in? 1, 2, 3, 4, 5, 6. So it's creating a new array, but it's also populating each spot in the array in the same order it's entered here with those values. So it's not going in with zeros, it's going in with values, right? So this is, they call this an initialization list, and, very common approach, by the way. Like if you know the stuff that's going in, then you just put in. Why not, right? Like if you, especially if you know those values, right? One of the advantages to this is you don't have to remember to use that new keyword, right? And you can only do this approach when you're first creating the array. So I can't, like, after I create it, then do this. You can't do that. You can only do it when it's being created. So in other words, I can't like make a declaration of a size and then feed it a value with a statement like this. That won't work. Even if I skip this part at the beginning. This whole approach works only when it's the first time you build the thing, so keep that in your head as well. All right. Another kind of interesting thing is every array, kind of like a string, and we learned this with strings pretty quickly, like how long is that string, right? Same thing, index value of 0, 1, 2, 3, etc. Every array also has a built-in property, or what we call a public field, called length. Notice the capital L, right? And notice how we use it. So here we have an array that we've set up. It's got 25 positions in it. And if I right line temperatures dot length, it reaches into that object extracts its length, and that's what this comes back with. This is a value that you can test for. And you guys noticed, like when I was writing my code before with the donations thing, it automatically defaulted to that, right? It's like, well, you want to run this up until the length of the array, duh, right? You know, it's kind of like the what Visual Studio was doing to us. But this is a property that's very, very commonly used when you're working with arrays, so you know where the ends and the beginnings are, basically. All right, so the comparison once again is, yeah, strings also have a length, right? So like if we looked at like this string, right, that's got a length. This array, which has 3 values, also has a length. So this would return 3, and this would return however many letters this is, like a bunch, 10 or 11, 12, something like that. You can tell this is an important issue. That's why it keeps coming up in the slideshow. It's very common, it says, to use an array's length in a for loop, right? So like what Visual Studio did for us. But notice when we're using the length and we're starting our counter at 0, which matches the array index values, we never say less than or equal to. We just say less than. This will give us that out of bounds error or off by 1 error, if you will. Right. Interestingly, length is a property that we can read from an array, but it's not one that we can set. So I can't like create an array and then say, well, you know what, now the length is 17. Nope, can't do that. It was already set. Remember that first rule, which was like, you can't change the size of the array after it's built? Yeah, weird. Right. It's not how it works in other languages, by the way, necessarily. All right. Another really interesting kind of tidbit here is this loop, which we kind of briefly mentioned last week when we were talking about loops. And then we were reserving it for this week because a for each loop is a type of for loop that basically allows you to automatically traverse a complex structure without all the fancy syntax that we do in a regular for loop. Yeah, a regular for loop will work just fine. So I can take this number array, right? I can test its length, run the loop up until the length, and do whatever stuff I'm doing. That works just fine. Regular for loop works just fine. However, compared to the for each loop, the for each loop does not require that you set up a variable, test the variable, or increment a counter. What it does is we take numbers, which is the array that we have, we come up with a variable name, usually the singular version of whatever the array name is. So like if it was donations, we'd say donation, right? And so for each integer number in the numbers integer array, if you want to read out the whole thing, right? It will automatically perform this task. There's no counter to increment. There's no length to check. There's no index values to be screwing up or messing up and being off by 1. For each will automatically traverse the structure. Cool, right? And if you think this is cool for a little short array, man, that is amazing when you have a really huge data structure you're traversing and you don't know how big it is, or it's so big you don't even want to look, right? So that's kind of interesting. And because it automatically adjusts, it's dynamic, right? So like you can throw any size structure at it and it'll just work. Cool, right? Super cool, and designed, by the way, to work with those complex data structures. All right, so the concept once again is it goes through the entire array all the way up until the last element automatically. Every iteration stores the next element in the variable called enum, right? So in other words, there is kind of a variable happening that you aren't seeing, but it is storing it because, I mean, how else is the loop really working, right? You're just not seeing them. You're not seeing and setting the settings basically, but it works automatically. That doesn't mean there's nothing there. Okay, there's some issues with this, so check out these issues. These are kind of interesting. If you're working with an array and you're using a for each loop, you can't change the contents of the array. So I can't take a value in the array, like if it's a number, and change it to a different number. Okay, so it's not useful, and listen to this, for putting stuff in an array. So, right? Because if I'm like prompting a user and then storing it in the array, I wouldn't use a for each loop because it doesn't allow me to change the array. However, it's very useful for reading information from the array to either be mathematically processed or output to the screen or to feed into a different process, you know, so any of that stuff. So you're just reading the information. You can't work in reverse order. So I can't tell a for each loop to start at the end and work its way to the beginning. I can do that with a for loop, though, by incrementing negatively and starting with a large index value and counting down. See the difference? So a for loop can go backwards, a for each loop cannot. It only moves forward, right? You also, the for each loop does not allow you to have any way to skip over stuff, right? If I wanted to skip over stuff with a for loop, instead of going like I plus plus, I would just go I plus equals 2, right? And I could do every other, or every third, or every 59th, or whatever. Also, the for each loop does not have access to the subscript value or the index number, so it can't use that for processing. Where in a for loop, we could. And, we had an example in the donations program where we were just using it to just show you which donation number it was with a little math, right? So we don't have access to that with a for each. So you have to think about when you're using this. Normally, like I said, it's to read a whole bunch of information and process it or output it. Typically, those are the two actions. All right. I think this is actually a really good spot to take a break. So why don't we do a 5-minute break? We've been going for a while. All right. So I'll see you guys at about 8:03-ish. All right, folks, let's move on to the next slide. Some interesting little things here that you should know about arrays, and this is, I think, pretty interesting in this language. Remember that once you have the array set, you can't change the size and you can't change data type. I know we already said that. You can, it says, reassign the variable to a whole new array. All right, so this is kind of interesting. So in other words, look at this declaration here. So here's the first array called numbers, right? So I can't change the size of it. But if I use the new keyword, I can restructure it. So in other words, whatever this was and whatever was in it, gone. It's destroyed, right? And then we have a new array, and in this case, it would be empty and filled with zeros. Now, the stuff that was stored here in all 10 positions, C# will do this thing we call garbage collection. And I think I've mentioned this real briefly, but that is whenever you're working with a variable structure in memory and you use the variable, like you use it inside of a loop, and then the loop's done, that loop will destroy that variable, and the language will actually go through, clear out the memory, and reallocate it back to the system so the system can use it for something else, right? So that process is called garbage collection. And I think I mentioned to you guys in like the old versions of the original C language, it's not how it worked. It did not garbage collect. And if you were creating a variable, you would also have to destroy that variable and clear the memory. So, and it was an important part. So all our modern languages, by the way, and we benefit from this, automatically do garbage collection. We don't have to think about that. It's enough to think about creating it. What a pain it would be to also have to take the garbage out, right? So C# does that for us. So the garbage collection is what we call automatic, right? And then they use this goofy little graphic here, right? So that's what we started with, was a 10-element array. We put that into the dumpster, and then we created a new one. The old one is gone. It's hauled off to the trash heap, basically. Interestingly, because arrays are basically a collection of variables, we can also use them to move around our program. So we can pass them as parameters or receive them as arguments, or is it the other way around, right? Pass them as arguments and receive them as parameters, whatever. But the array is capable of doing that, right? So you can throw it into a function, um, and it has an interesting aspect to it though, because it's passed by reference, and this is really kind of an important concept here. We're going to kind of delve into this a little bit as we proceed, but that means that we're not really sending the actual stuff in, we're sending a referral to it. So in other words, if I do something inside that function to that array structure that I'm passing in, it actually changes the array, right? So think about this, like if I was doing a regular variable and I was throwing it into a function, by the time it gets to the function, it's really a new variable. And if I do something to that variable, it doesn't affect the original one from where it came. You see the difference? This approach, when I pass an array into a function, the array can change. The contents of the array can change. So be mindful of that. And that's called being passed by reference, by the way. If I can pass one in, I can also send one back. So I can do a return type from a function that is an array. So for example, this goofy one here just sets up an array and then we're sending it back to wherever it's called from, right? So that's a possibility too. So you can send them in. They will change in there though, so fair warning, or you can send them out, right? So either direction works just fine. All right. I'm going to skip over this little try it up. I hope you guys don't mind. But if you wanted to try it on your own, this is probably a fun little one to check out. It says, write a true false quiz with 3 questions, use 2 arrays, one with questions and one with correct answers, right? And then you would prompt and then you would give the answers and then you would check to see if they're correct, right? That would take a little bit of time, to do. So I want to skip over it and save the time if you guys don't mind. All right. Let's move now to this other subtopic here called array algorithms, because some of this is useful. I'm going to say for the most part, this stuff is more informative than necessarily used in our homework as deeply as it's as it's presented here. So just be mindful of that. But the information is important so you understand how arrays really operate. All right. If we had this thought of copying an array, okay, so let's start first with creating one. So we have array number 1, which has got the even numbers up to 10. Put in it, right? Then if I wanted to create another array, and then I just would take array 1 and put it in there. Well, first of all, can I do that? That's a good question. And the answer is yes. I can take one array and attach it to the other array. So the concept is that, okay, well, now I have 2 arrays with the same stuff in it, and they're 2 separate arrays. Okay, this is where it gets weird. No, that's not what's happening. What we're really doing, and this is the reference thing coming into play again, is that first array and the second array are actually sharing the same memory addresses. So if I change something in array 2, it also changes in array 1 because it's the same array. Weird, right? Same thing I encountered. I was teaching my Python class last night, and they have a structure in Python called lists, right? Very similar to an array. And the same thing happens. If I copy one and copy the other and make a change, both change, but really they're both referencing the same spot in memory. So very weird. So what we're really copying here, right, is the memory reference. If you really want to create a second array, you have to use the new keyword, right? And so I would have to do what I'm doing here. So I would just declare the first, make another one, and then I'd have to go through the process of copying the array contents, right? Weird, right? It's not as straightforward as you might think if I want to make a copy. So what they've done here is they have a function, or really a method technically, called copy, and the parameters for it are which array do you want to copy, which array do you want to copy it to, and how much of it do you want to copy. just in case they're not the same length, right? So once again, it's on you to know the length, but that's the copy method. So we would have to go through that process technically. We'd have to create the one array, create a blank one, then run array copy to copy the contents of the one array to the other, and then they're the same. Weird, pretty weird. Another method, very similar one, by the way, notice the syntax difference here. This method, right, you say array dot copy, copy from, copy to, and length. And then this one, which is the copy to method, where we take the first array dot copy to the second array, and where do we start copying from? Index position 0. Now this assumes a few different things here, but a congruous size is one of them, or at least what you're copying to is at least the same size. Right, so these are real little nuances, you guys. All right, we also have sometimes the need to say, okay, I got this one array, I got this other array, and here's an example where we have students and teachers, right? Each one is a string array in this case. And I'm asking an if question, and the if question is, if students is equivalent to teachers, we can write line the same, otherwise we write line different. Okay, so this is weird. And here's the question. It says, what question are we really asking below here? All right, this is where it gets weird again. The equal sign is really used to compare things, right? And that's why I always use like the word equivalent to, right? It's not equals, it's is this equivalent to that, right? And that's for the comparison's sake. So you're asking if the variables contain the same memory address. So equal when it comes to arrays is asking, are we referencing the same memory address? Weird. This goes back to that reference thing again. And so really the question is, does address A equal address B? And no, that's not really what we mean by it, but that's how the computer interprets it. So be mindful of that, right? So really, what we're wanting to ask, and here comes that word equality, right? How do we ask, do two arrays contain the same values? That's actually the question, right? That's kind of the point. Use the arrays sequence equals method to determine this. And so in other words, what sequence equal does as a method, right? So it's a function basically, is it looks at each memory address and says, does this memory address equal that one? Are they the same values in both index zeros? Okay, great. Green check mark. Does Brittany equal Brittany? Yes. Matt equal Matt? Yes. That's what this method does, right? So that's one that you can utilize. And if you want, you can also, if you guys are noticing, this is a link, so you can link out to, of course, it goes to screen number 2, but you can link out to Microsoft here. If I can get past the ad. Let's try refreshing, right? And then you can try some of these like goofy little examples that they have here, right? And notice the way that sequence equal works, right? It's kind of like that one other weird one where you say the first array sequence equal array 2. That's how you do the check on it, basically. Right. I also want to show you that you can, some of those links are actually links. It's control click to go to them, by the way, if you didn't know that in the PowerPoint. All right. Now for some of the slides coming up here, when they start talking about some of these methods, you'll notice that they say use system link. All right, so I want to kind of explain that a little bit before we go too much further with it. But whenever they're saying something like that, that means that we're going to add basically what, I think of it as an import statement, right? But in C# we say using instead of import. If you're used to Java, for example, we use the import keyword. If you're used to Python, we use the from keyword. In C# we say using, and then what they're referring to is system dot L, I, and Q. And that brings in a whole library of methods that are built for dealing with complex data structures and collections, arrays, collections, and other complicated objects. And LINQ typically is used with database stuff, by the way. Um, but whenever you see that on a slide and they're talking about it, this is what they're talking about, right? So if you want to try some of these, it's required that you put this up at the top. Otherwise, the code doesn't know, C# doesn't know where to pull it from, right? You have to tell it which library are you including. Will pull all of those methods and functions into your program so you can use them. And that would include the sequence equal. So for example, to really compare them, once again, we would say if this is the students array and this is the teachers array, we could then run sequence equals. So we could say students, sequence equals teachers, and we pass the one in as a parameter for the method. And if this comes back true, then we will output same. So this tells you that when you run this method, what's the output of the method? Well, it's true or false. Are they the same or are they not? You know, that's the return result. Now, it's not the only method that's included in these libraries. So there's a whole bunch of them, right? And this is really scratching the surface of them, but some of them are really useful and common to use. Another example would be sum. So if I have an array that's got a bunch of values in it, I can use the sum method to total all the stuff up that's in the array. So once again, you have to use that system link library to get that to happen. If that's not at the top of your document, it's not going to do it. All right, moving on. Well, what if you want to do the average? All right, well, think about this, right? If we took the length of our array, right, and we kind of did this, right? But is that how we did it? We did it with a counter where we did that example exercise, but we could have also done it with the length. We didn't even need to count. Interesting, right? That didn't even occur to us when we were doing it, but that's a possibility because the length of it is the right amount if you're going to average it. Now, if you combine, right, the sum with this approach, well, then you have the average. It's really super easy to achieve it without writing formulas or anything like that. It just kind of does it, right? Other interesting tools that are built in are min and max, right? So you can look at a whole collection of numbers, find the biggest one, or find the smallest one, right? Once again, uses the system link library for that as well. Another interesting feature about like the contents of an array is there is a method that allows you to sort the values in the array. And this can be pretty useful as well. So if I have a list of numbers that are out of order and I want to order them, I can just run the sort method, right? Notice it says you can also use it to sort strings in case sensitive dictionary order. So it recognizes upper and lower case and can alphabetize your string. So if you have like a list of, I don't know, last names in an array, I can order them using the sort. And of course, the sort is ascending, right? You start with the letter A and move on up. Same with numbers. Right. Kind of another interesting concept is as soon as we start having an array structure, and then we have multiple pieces of data that we also want to put into an array structure, we can take two different arrays of the same size and call them parallel arrays, right? So for example, if I have like a list of weekdays and then I have a list of classes on those days, right? So in other words, intro to C sharps on Monday, intro to sequels on Tuesday, you know, et cetera. And you see how they alternate. So like Monday, Wednesday, Tuesday, Thursday, except or Tuesday, Thursday, whatever. But these are really two separate pieces of information. So we have one array of strings called weekday, a different array of strings called classes. They're not really related. To us, they are because I just said they were. But really, inside the computer's paradigm, they're not related. So the point is, if you have two arrays that are related to each other, at least in your mind, it's up to you as the programmer to make sure that they work together in the code so that they behave that way. It doesn't happen automatically that C# will go, hey, these are both the same size. You want to relate them together? This is not a database, but if you learn database stuff, that's exactly what happens in a database, is that relational aspect. But I think that this is really kind of an interesting aspect because it's a conceptual thing that there's a relationship, and you have to think about that. Now, kind of interesting, if you are working with two arrays that have different information and you want them to work together, once again, conceptually, you can take the two arrays. For example, you can take these two arrays and send them to array sort, right? But what's it going to sort? With the first one, it's going to order them alphabetically. And with the second one, it's going to order them numerically. And it doesn't mean that the sorts will work out the same way, right? The assumption is Aaron's getting a 3.75, Jose is getting 3.9, and Alicia is getting 3.81. But if I sort these, the numbers would stop matching the names, right? So that's often a goal then, is if you have two arrays that are hypothetically linked together, it's up to you to figure out a way to keep that data matched together. Have you guys ever done that in a spreadsheet, like sorted information, and then you're like, oh wow, did it mess up the other columns? Yeah, and it can, right? If you don't do it the right way, it totally can, right? So the same applies here. So you got to be mindful of it. All right. So there is a tool though, right? So if I wanted to sort two arrays hypothetically together, so in other words, to sort both arrays alphabetically by student name, I can use the sort method and I would feed in the one that basically is kind of the guidepost first. So we want to sort it by student name is really what we want, but just make sure that the ones that are in this array that were in the same position follow the sort that happens with the students. That's what it's saying, right? So we could run that sort and it keeps the information together. The names are now in order, but the GPAs are not. If I would flip those two around, the GPAs would be in order and the names would not. Right? That's kind of the difference between those two. All right. If I wanted to sort it with the number, so here's the converse example, you just put the GPAs first. Right. So that's kind of the example there. All right. We are now coming up on a try it out here, and I'm just going to pause momentarily. All right, we debated a little bit. Mostly I did the debating, but we're deciding that we're going to try to code through this just for the heck of it. All right, so we're looking at this scenario here, and what we decided is basically that what would make a whole lot of sense is to have an array of strings and then an array of integers. These integers would be manually entered by the user. So we would prompt them probably in a loop. So in order to make this as kind of efficient as I can here, I'm going to use the program I did before, and I'm just going to comment everything out, right? And then I'm just going to kind of leave it alone, basically, just in case we can borrow some ideas from here. I'm going to leave the link thing in at the top. And we're going to go ahead and try to code this. So I think the one thing that we said is we could have a string array. What should we call that? Days. We'll just call it days. That sounds good. And we could pre-populate the array. We just brute force do it, right? Did they have a 5-day list? Yeah, 5-day list. So if you remember, you use curly brackets to do this. So I could just do Monday, Tuesday, I'm kind of waiting for the IntelliSense to kick in, but it's not doing it. And a semicolon at the end. So there's our array of the days of the week. And then we need an integer array that's going to hold intrusions. We'll call it intrusions. And this is kind of trivial, but notice that when I'm naming this, because I know it's going to hold multiple values, and this is kind of an automatic for me because I've done it for so long, is I name it with a plural name because it's not going to hold just one intrusion. It's going to hold many. You see the logic there? Right. All right. So intrusions, we're going to say new int square brackets and the size. How big is it going to be? 5. Right. 5 days of the week. And so there it is. All right. So we created this. Now we want to prompt our user. Could I just borrow something like this? Yeah, I know the code's not right, but we'll fix it, right? And what's the actual question that we're going to ask? Actually, let's set the loop control variables first. Should we start counting at 0? Yep. What should we count up to? Well, we know it's 5 because it's hard coded. But do I want to run it against the length of one of the arrays? I'm not really sure. We could, yeah, I guess we could just use the number 5. My inclination would be to use the length just in case we want to make it dynamic, but we'll just leave it at that. And we'll say how many intrusions, and we can dynamically pull in the name or the day of the week, right? Like inside these curly brackets here, I could literally say days sub I, and it'll start with Monday. How many intrusions on Monday, right? That works. And so I'll put a question mark here. And then the neat thing is they'll go, how many intrusions on Tuesday? How many on Wednesday? How many Thursday, et cetera, right? And then we're going to store that in intrusions sub I to match, right? Are we converting to a double? No, we're converting to an int 32 in this case, and we're still redlining. All right. We don't really have any need to take a total, at least not right now. All right. So would this capture all the information? Yes. Okay. So then I think the goal would be is to kind of mimic this. We'll have a little table here or enter intrusions. And see, they're not even asking the question. They're just putting the day of the week on there, right? They're just saying Monday, Tuesday. All right. So I'm going to do the same thing. I want it to look just like theirs. And actually, we're going to want a console write line up here. And I think they did their ASCII art, which is like enter number of intrusions. Okay. It's about as fancy as my ASCII art gets here, folks. All right. And then we'll do the prompt. Let's see. Is that all they're asking us to do? Prompt the user, enter each day's count. Okay, yeah, this is all of it. Let's go ahead and do it. All right, so we're going to run this. Let's just make sure this part works, basically. All right, so for Monday, 5, 2, 11, 23, and 1. Okay, so that works. Yeah, it's not the prettiest thing. It's almost as pretty, but not, it's pretty. All right. Let's go to the next slide because the next slide has the other questions. All right, so let's see if we can accomplish all this. It says, once the data is entered, list the days and number of intrusions. So we want to put it back up on the screen. Okay, I think we kind of already did that. Would you guys agree? Like right when they were typing it, it was there. Okay, done. Total intrusions for the week. Well, now we want to keep a total, right? So let's just do this one bullet at a time and kind of proceed that way. So let's do a total. So I think we're probably going to need and I'm putting a blank line in there, by the way, a variable. Will this be an integer? Yes. So we'll say int total. Okay. So wait a second. Should I use a total? So here's how my brain's thinking. Like I could just do the way I did it with donations. Every time they enter one in, I can add it to a total and show people what the total is, right? In fact, here, let's just do that just for the sake of it. We'll start it at 0. And then here we'll just say total plus equals, what would it equal? Intrusions I, right? Whatever value they just typed in, that's what it would equal. And then at the end of it all, we would just simply console right line, let's string interpolate. And what would we right line? Total intrusions. And then we would put in our curlies and we would just display the total. Right. And this is absolutely a fine way to do it. I mean, there's nothing wrong with doing it this way, but we were taught some functions that we could also use to see the kind of the point here. So let's just run this and make sure it works. All right. So Monday, we got 1, 2, 3, 4, 5. I want easy numbers to calculate. What's the total of that? 15, right? So total 15 intrusions. All right. So that works. That's one way to do it. However, right, so we are never satisfied with that way. All right, so I'm going to do this. What's a different way that I could total them? Well, I could, I still would probably use my console right line. So let's go ahead and borrow that statement. But could I instead, inside here, take intrusions, if I could spell it, and then just use the sum function from intrusions. Now, interestingly, I forget if this one's part of that library or not. Apparently not, right? Because notice I took it away and it still doesn't underline, but I'm gonna leave it there just in case, because I know there's others that we're gonna use that probably will. Would this do the same thing and would it give us the same answer? What was the answer? 15, right? All right, let's try that. So 1, 2, 3, 4, 5. Okay, that works too, right? So there's an example of using the function. You could do either one, right? So one of them crossed off the list. Well, two of them crossed off the list. Okay, what's the average intrusions per day? Okay, do you remember that little example from the slides just a couple slides ago? All right, so we're going to right line this, right? But do we want to do the math separately? Do we want to create a double called average? And then what's average going to be equal to? How about this, which is our total divided by intrusions, a very smart Visual Studio dot length, because that gives us the total, right? And the count. Even if I don't know the size of the thing, it does it automatically, right? Stores it in average. And then if I want to right line it, I can just copy this and average intrusions. And we're not going to do the sum here. We're just going to output average. All right. So some of you are going, could I have put this inside here? Sure. Yeah, you could do that. That's absolutely fine. Whichever way works for you. Let's try it. Okay, 1, 2, 3, 4, 5. What's the average? Right, 3. Right, 15 divided by 5 is 3. That's correct. All right, so very good. Next. Day with the highest number, day with the lowest number. Sounds like min and max to me, right? All right. So could we, I'm going to borrow this right line and you can say max intrusions okay, so is it really okay? So here's the next question. Are we supposed to list the day with the highest ones, or maybe list the day and the number? Well, we can see the number, right? Well, we can really see it from the list above. But if you want, you could say max intrusions, and I could say in. All right, so how would we correlate? See, how do we correlate those, right? All right, let's just do it like this. I think that's probably the easiest, just to kind of move on. And then this one could be min. All right, let's run this again. Okay, max intrusions are 5. Min intrusions are 1. What else is it asking? Anything significant? Use 2 arrays, one to store the names of days. Okay, we already did that. Okay, so we completed the try it out then. So that wasn't too bad, right? We got it all to work. If we wanted to really correlate the information, though, that would be a little bit tricky. But notice that they did do that here, didn't they? Yeah. So how did they correlate the two? What mechanism would you use to correlate them? Now this is where the sort thing comes into play, by the way, right? So we would have to do an array sort. We could sort it from highest to lowest, right? Would that seemingly be the right way to do it? Because I mean I could easily just hard code Friday as the highest and Tuesday as the lowest or whatever, right? But how would I dynamically generate that? Okay, that's really kind of the challenge here. So any one of these methods you think might work? Would the sorting do it?
I think so, right?
Yeah, but okay, so here's the question, right? The max thing looks inside there. Okay, so here's kind of the magic way to do this. All right. If I sort the numbers, and I want you to think about this. If I sort the numbers will order from smallest to largest, right? So which one is going to be the largest? The one in the last position. See the thinking, right? And then if I move the days of the week along with it, then I can pick the last position from each array and just output that. Right. So we can use the max and the min, and it's okay that we did, but let's do the array sort. And which array are we sorting? Well, it's implying that we should sort intrusions, and we should do that, but we should also make sure that the days are sorting with it in the same fashion. Okay. And then we're going to have to test this, of course, right? Because then we're going to have to output a fresh thing. And we're going to have to say days, and we want the last position of days, right? So that's going to be the array is size 5, so that's position 4, right? And I could do this dynamically, and really that should be in curly brackets, right? Okay, so like Tuesday had the, how they word it? Friday had the most, Tuesday had the least. Friday had the most, and I think it shows the number. And so then we would just put in intrusions 4, correct. All right. And then we'll just copy that and then use the first position, position 0, for the least. All right. Saving and running. Let's make sure that it works. So I'm going to kind of mess with it a little bit though, because so far it's always been Friday. So if I sort Friday as the highest, it's kind of going to mess things up. So I'm going to put in some weird numbers here like that. Okay. Wednesday had the most? Yes. Tuesday had the least? Yes. Pretty clever, right? I mean, simple but clever, right? And all the other algorithms work. I think that was a nice little exercise, right? It got us to play with some of those techniques that they were talking about in the slideshow. Anybody get stuck on it at all? Everybody's code's working all right? For those of you trying it, fantastic. All right, let's keep pressing forward, folks. I'm going to get back over to the slideshow here. And now we're going to deepen the waters just a little bit, right? If we haven't gone down this rabbit hole far enough. When we build a singular array, you can kind of think about it as like a row in a spreadsheet. Like think of it as, an Excel spreadsheet, and you're just dealing with row 1, or row 0 actually, right? And then you might have separate columns in that row to store individual pieces of information. That's totally how a spreadsheet works. And then the next time you open up a spreadsheet application, can you appreciate the fact that each box in the spreadsheet is kind of like an array position that takes a spot in memory with a unique identifier that you can manipulate? So, wow, pretty interesting, right? Like the one data structure feeds into the next. And basically what happens is when we take arrays that are of the same size and shape and stack them, we get what we call a 2-dimensional array, right? So we can do this conceptually in this language, right? So we can actually set up multi-dimensional arrays, and it's more, once again, of a conceptual construct than it is anything else, right? So, all right, so let's just kind of move forward with this and just kind of take a look at the syntax of this, right? So notice we still are using square brackets, right? So this declaration says we are building a multi-dimensional array. And then when we declare the size, we use 2 values, 1 for rows, 1 for columns, in that order, rows and columns. 2 rows, 3 columns. Right, interesting, right? Notice all one data type though, right? It's not like a spreadsheet where I can have a header and type in some text. This is all going to be numbers, nothing but numbers. Another way you can do it, and this is kind of interesting, is instead of just setting up an empty one, right? This would be populated with zeros. You can also use the curly bracket approach. This is kind of clever They have an outer set of curly brackets. And then inside there, they have two sets of curly brackets separated with a comma. The first one is the first row of the table, and the second one is the second row of the table. But still, two rows, three columns. What I like about this approach, at least in terms of like hard coding values in, you can kind of see it, right? I visually can look at this and go, aha, yeah, it kind of looks like a table, right? This is a different way that you can do it. Now, we've figured out how we access stuff in a one-dimensional array with a single index number. But when we're working in 2 dimensions, well, now we have to use the nomenclature of row and column. And always remember it's in that order, not alphabetical, right? Right. So some people will say columns and rows, and other people say rows and columns. Here it's rows and columns, right? And those sub numbers, notice how each one of the boxes corresponds to those numbers. So if I want to get this box, I refer to it as scores 1, 0 inside of square brackets, and it refers to this memory location. And each one of these has a unique identifier, but we still have only one variable name. Okay, so this is like the syntax. So for example, this statement here would take the value of 29.75 and place it into this memory spot here in the table. Right. And I think of a 2-dimensional array as a table because that's what it is, right? That's what it looks like. Right. 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 When you are creating 2-dimensional arrays, very common, once again, is to use constants to declare your rows and columns. And then you can throw it in there. And this is one way to also kind of help remember what order they come in, by the way. But once again, constants are commonly used to set the sizes of array structures, just in case you want to change it later, right? All right. If you wanted to access the contents of a multi-dimensional array, you can still use loops. Okay, this is where it gets weird. But since I'm traversing both rows and columns, each is a repeating structure. So rows are repeating and columns are repeating. I would have to nest my loops in order to traverse the structure. So in other words, if I have like one loop inside of another, the outer loop addresses the rows and the inner loop addresses the columns. So in other words, we first start with row 0, that's the outer loop, and then we go through each one of these, that's the inner loop. Then we go back to the outer loop and iterate again, and go back to the inner loop and do it 4 more times, outer loop, inner loop, and then the loops are done. But the one that does the across the row, or each column basically, is the inner loop to the outer loop, which is the rows. That's kind of the point of it, right? So this is a nice little example, right? So the outer loop controls the rows, the inner loop controls the columns, and then notice as they're kind of like outputting the contents of the table that they're doing a row and column thing. And not only that, but this one would right line it, keep it all on the same line, and then after each outer loop runs, then you move to the next line. So you could even output it so it looks like a table. And with some clever ASCII art stuff, you can make it all line up too. It's not too hard. That's a nice little example. I like that one. All right. Okay, so it says here, what's the difference between using a for loop and a for each loop? All right. What's the answer? Yes. So the concept is for each score in scores, would this for each loop traverse it? That's kind of really the question. And the answer to the question at the top of the slide. So if we're just right lining it, we're just, remember, can't change the stuff in the array or the table or whatever with a for each loop, but I can output it and look at it, right, or process it. So the answer is yes, I could traverse the whole structure that way. How would it proceed? with the same nested loop structure that we saw in the previous slide. Each one row at a time across each column, and it would follow that pattern. And it does that automatically. All right, folks, I think we're at another good break spot. So when we come back, we're going to talk about collections. So I'm going to pause the video and we're going to take another 5-minute break. All right, welcome back from break, everybody. We are now going to look at another concept here called collections. And this really covers kind of a broad area of programming, really. What we've been kind of doing here today is we started out with a simple array, which is sort of like a variable that allows us to hold multiple values, like having multiple variables, basically. We also learned that you can kind of ramp that structure up so you can have like arrays that are parallel to each other and you can kind of sort them together. And then we started creating or looked at the creation of multi-dimensional arrays, and we normally think in 2 dimensions, but it is possible to take it farther than that. And then that leads us to here, because generally speaking, this whole thing that we're talking about collectively are called collections, right? And we already looked at the very first type, including a multi-dimensional array, but there are other structures as well, right? So there's array lists, and there's lists and dictionaries and queues and stacks. And I'm going to sound like I was talking to my Python group yesterday, in that this whole concept of like when you're taking data and you're storing it collectively into a collection, and it really becomes a complex data type. When you go on and you study it like on the 4-year level, like you're studying computer science and you're working on a bachelor's or maybe a master's degree, they have entire courses just on data structures, which are really built around most of the concepts that we're talking about today. We're taking a pretty superficial look at them, but when you study data structures, I mean, man, it becomes a thing, right? Because these are ways to sort and organize information that are created to be kind of similar to each other, but different, with different capabilities for different usages and different purposes. And were created out of necessity, often to kind of simulate like real world situations or to solve real world problems, right? And we're just scratching the surface. So we're going to kind of come our way down this list and address a couple of these here tonight, including lists and dictionaries. Those are the other 2 that we're going to focus on. All the others are learnable as well. They're just different data structures, and they take kind of a different set of knowledge, basically, to kind of do that. Okay, so let me dig in here and go to the first one that we're going to talk about, which is a list. And this one's kind of a good natural next step, because it's so much like working with an array that it's almost the same. There's a couple differences, right? And notice it's similar to array, except its size increases dynamically. So it's not stuck at the size that I initially create. So if I keep adding stuff to my list, it'll get bigger. Very nice. That's pretty helpful, I think, right? You also have to specify the data type, so that part of it doesn't go away. So if I'm creating a list of integers, it's going to be a list of integers, not strings, right? All right. So what data types can you use? Like all the same ones, basically. All the ones that exist can become lists. All right. How do you add stuff to a list? All right. Well, once you create it, now why don't you notice the syntax on this, right? Similar, except we're using brackets instead of square brackets, right? And then we're doing this list angle bracket thing and then parentheses at the end, right? This is kind of weird, right? And easy to forget to do. And you'll be thankful for IntelliSense when you do use it. All right. So how do I put stuff in the list? You can do it using methods, and typically the most common way to add stuff to a list is to use the add method. And in this case, since we're adding integers, I just call it by name and then append the method with the value that I'm sending to it. Now, the list running these commands will add the numbers in this order. So the first position will get 5, then 4, then -7, then 0, then 33 in that order, right? And the list isn't capped at a certain size, so I can keep adding to it. Not a problem, right? I can make it as big as I need it to be. So what's the one reason you would use a list over an array then? Well, if you don't know how big it's going to get, a list is a better choice than an array, right? If you know exactly how long it's going to be, like the days of the week thing, there's only a certain number of days in the week. We know how big it's going to be. We don't need a list for that. But we might not know, for example, how many people walk in through a business and throw money into a thing. This would dynamically adjust to it. You can also, with a list, and here's an example of one that's a list of strings, you can actually use all the same naming. So the creation part of it, the creation line, still is basically the same. No parentheses at the end, though, but a set of curly brackets like an array with the hard-coded comma-separated values placed into it. So this is like the brute force initialization approach. You want to create a list and just put the stuff right in there. There you go. I don't have to use add, but I can only do this when I'm creating it, right? It is problematic though, right? If you declare a data type, and I think this is pretty intuitive, and you're telling it to add values, right? This is an integer. This one will fail because it's a floating point number. And this one will fail because it's a string, because the data type is integer. Okay, that's pretty normal for any kind of a variable. And if you just think of a list as a complicated variable, same difference. So when you work with a list, then how do you access all the different positions in it? Well, the good news is the same exact way you do with an array. You still use square brackets to access the stuff. So this loop here would loop through all the colors and it would output red, green, or red, blue, green, pink in that order, because that's the order that they're in there, because we're starting at position 0. So red 0, blue is 1, green is 2, and pink is 3. It is a list of size 4. And notice how they figure out the size. They don't go length here, right? So when you have a list, the way you measure its size is with count. And the count can change. And that's kind of cool. So can I use loops to traverse my list? Well, we already actually saw an example with a regular for loop, but you can also use a for each loop, and that will also automatically traverse the structure. Couple little nuances here, and I don't know if you guys are picking up on these or not, but like here, you notice the keyword var as opposed to the data type that it actually is, which is string, right? And this works, by the way, and is not uncommon in these situations. And you'll see why when we get to the dictionaries, because that becomes very flexible, a very flexible tool, basically. All right. So moving on here. If I want to insert an element into my list, now this is kind of an interesting thought here. So I have this list, and now I want you to notice another little nuance that they did here. And these are like the subtleties that you might miss as you kind of move along. But you notice how like they switched from saying list, brackets, string, right, colors, to just saying var. And then on the other side here, it becomes a list. That's still the same thing, by the way, right? Just if you're wondering about the syntax change, this is a valid approach also for creating it. But the insert statement works like this. This is actually saying go to position 2 and insert cyan. So starting, this is 0, 1, 2. Green is in position 2. but we're going to take cyan, put it there, and then take all of this stuff and just move it over. So cyan goes into position 2, green and pink just get pushed up 1. So that's kind of a thing that we can't necessarily do with an array. So we're pushing the content in to that one spot and then moving all the other contents over to accommodate for it. Right. So that is one interesting technique, and it works off of the index number, same index numbers we've been doing all along. Right. If we want to do a removal of something from a list, we can also do that. So this is kind of interesting because it also changes the size of the list, right? So I can go and do it by position number. So I can say remove at position or index value number 2, right? Which would remove what? Green, 0, 1, 2. So remove at 2, it would get rid of green. And then if I followed that command with remove blue, because I can also search for the value that's inside there, it would remove blue and green. And what would we be left with? Red in position 0 and pink in position 1. Kind of a neat little aspect of this. So lists become really flexible at kind of like moving around stuff, adding stuff, removing things, getting rid of them, removing them by the contents, removing them by the position. We can do all of that with a list. Right. There's another method that comes with a list called contains, and it says this method is used to test whether a list contains the given value. It returns either true or false. So for example, if I look at the list colors and it contains red, well, then I can do my message. Okay, I don't want to give them this message if it doesn't have it, right? Notice here, if I want to look at the opposite, right? If I don't want to find white, so like not contains white, but not contains white, that's how that reads. That would indicate that it doesn't, right? So the negation character flips the sign on the true false. So folks, that's lists. And I'm not playing with any of these structures in code right now. And frankly, I forget if the homework includes that or not, but this is kind of an interesting structure that you can use, and often use in place of arrays. Now, there's another important collection type that really has gained a lot of prominence in recent times. It's been around like a long time, but for whatever reason, in the modern world of programming, when we run an app on our phone or maybe our desktop or go out to a website or something, and we're interacting with a website that's really an application, a lot of times the data that moves around those websites moves around in this technology called JSON. And what I'm going to do here is I'm going to bring a browser tab over, and I'm just going to type this. Oh, that's not what I meant to type. Okay. All right. So as you can see here, it's what we call JavaScript object notation, right? And the whole point of this is the way that I want an example of it. All right, let's just go to W3 schools. It's probably good, right? And I'm going to kind of zoom in on this just a little bit so you can see it. But JavaScript object notation basically looks like this, right? It is curly bracketed information that's separated by commas and then travels in pairs. One part of the pair is the key, the other part is the value. And you can also think of it as like this would be the column in the table that it would belong to, and this is the data that it goes with. The column and the data, the column and the data. And this is called a key value pair, right? And so this has become so prevalent in programming now, it's really become the number one transmission medium when I'm like outputting from, let's say, a database and I'm feeding it into an application, and then the application runs and outputs some data and throws it back into a database. It often travels in these key value pairs, right? And this has become very popular, and this is known as JavaScript object notation, or JSON. All right, So put that in the back of your head. Maybe forget about it until you take your JavaScript class, right? And then take a look at what a dictionary is and notice that it's a collection type that stores key value pairs. So the same concept. So, for example, the key value pair can be of any type of data. The difference here is that the key value pairs must stay consistent in their formatting. So, for example, if my key is an integer and I declare it as such, and my values are strings, they will stay in that format always, right? JavaScript object notation allows you to break that rule, by the way, but that's a whole separate thing. The point is, when we're putting information into the dictionary, it travels in pairs, right? And the formats that we've declared here. So the key is the number, the value is the string in this situation. Is that always how it has to be? And the answer is no. This is really weird. So sometimes the key can be a string and the value could be a number. For example, think of our cybersecurity intrusion thing. The day of the week would have been the key, and the number of intrusions would be the value, right? Here, it's the other way around, right? It's all of this is about logic, and how your program operates. But if I want to add stuff to my dictionary, I use the same command that I do with lists, but I have to add it in the key value pair format, in the format that it's designated to exist. So in other words, if I say the keys are ints and the values are strings, I better feed them in that order. So I can use the add method, and this would add them one at a time. And like a list, dictionaries are dynamically sized. So I'm not pre-declaring its size. All I'm doing is putting stuff in there. It dynamically adjusts to the size it needs to be. Another way to add stuff is I can use the square bracketed sub numbers or index values. And I can just say, hey, in days position 4, can you please put in Wednesday? And I want you to notice that by declaring this, that's implying that the key becomes 4, right? So it does the same thing that this does. Kind of an interesting thing. So it declares position and value. Now, when you're pulling information out of a dictionary, right? So I'll put it like this: like I can go to the index in the back of a book and look up a term, and then that will tell me what page it's on in the book. That's kind of how this works. So if I was looking up the key value of 2, it would go to that structure, right? It would look up the key, but it would return the value. This is the lookup. That's what it's giving me back. So when I do this and I put a 2 here, it pulls back Monday because that's in the second spot. Or that's the key that's associated with Monday. It doesn't have to start with 0. It can be whatever we want it to be, right? It could be 532 could equal Monday. We don't know. Now, weirdly, these are key value pairs, right? And you can almost kind of think of it as a multiple dimension table or array, if you will, in a sense. But you can also iterate over this too with the for each loop. And I want you to look at the couple of variants that you have as options. So you can actually use this as the keyword, right? So you can say the key value pair and then declare, with the angle brackets and everything, int and string, entry and days, and you can iterate, and this works. So I could just go through the list, the dictionary, and it would output all the keys and all the values. That would do it. But look at this alternate approach on the next slide. You can also just substitute all this, right? And this is why programmers do this, which is var. And then you just use any generic name for it, whatever entry you want. And then you can still extract the key and the value right? So this is what attaches it to the dictionary. This is what we call the variable as it's going through the loop, but it still has access to the key value pair, right? And we can look at both. That's the other neat thing about this. It's kind of like, you know, kind of like an index value, but it's not. It's a key, right? You can create a dictionary brute force, by the way, by doing this. So you can actually um, hard code it, right? And think back to like when we did the multi-dimensional array where it kind of formed a table and we hard coded the values, and then it's inside of curly brackets and then more curly brackets separated by commas, and you can put in all your key value pairs like that. And I'll tell you what, this is where it starts looking a whole lot like JSON in this format, right? If you remember, the JSON has outer curly brackets, key value pairs separated by commas. The difference in JSON is this is usually a colon, in between them, but that's how JSON works. This is very, very, very similar, right? So there's a strong correlation. This is a really good data structure for a lot of situations, especially if you want the key to travel with the value so that when you receive the value, you know what it's attributed to. Right. So I think that's kind of an interesting piece. You can also use a dictionary to see if it contains a given key. So, for example, you can run the contains key method here before you try to extract the value from it. So, for example, you could say, hey, if days contains this key, then go ahead and write it out to the screen. But don't do it unless it's there. See the thinking? All right. So that's going to cap our lecture for the evening. There is a try it out together, but I'm not going to run through that. We've gone through a lot of heavy material here tonight conceptually. I don't know if you guys feel that, right? When we get into collections, this stuff gets pretty deep pretty quick. We do have our lab assignments, and what I'm going to do here, we're clearly not working on that tonight, right? But we will work on that next time we get together. And what I'm doing here is I'm kind of fast forwarding to the lab, but I just want to show you that we're not working with dictionaries. We're not working with lists. We're going to use arrays on this one. So the first one's an array. And then to the assignment, right? This one will use a list, right? So one will be based on lists and one will be based on arrays. I think what I'm going to do here is if you guys are burnt out for the night and want to move on and you want to leave, you're free to go. I'll let you go. But I think what I might do just to kind of reinforce the usage of lists is I'd like to go through and just kind of build this goofy little list here and just play with a little bit of the code that's been provided, just so we have a little background when we get together in the next session, that at least we've tried lists a little bit and see how they work. Right, so you guys want to hang out? That's totally cool. I'm going to let the recording roll on this, may as well. And I think what I'm going to do here is, you know what, I'm going to label my sample code. And then I'm going to, so in other words, I'm not going to get rid of this code. I am going to, oh, it doesn't like that, does it? Let's do that. I just want to comment out everything I need to comment out here to keep it all comments. There we go. Doesn't like that either. I have too many nested comments here, right? And I think maybe if I switch to this approach, I think there we're good. Okay. And then this one I will label, don't know, 2 arrays. And now I'm going to play a little bit with lists, and I'm just going to put in a comment here at the top, playing with lists. All right, so let's just borrow from the slideshow here. So I'm just going to create a new list just the way that they're declaring it here. So I'm just going to call it my list of integers, and now I'm going to start adding stuff to it. So I'm just going to say my list, add, okay, well, 1. All right, fine. 2, let's do that, but let's change the numbers a little bit and go like -7. I think as they did something goofy like that. And then they probably had like a 0 in there. And then we might want to try to add a string, right? A string would work. No, right? Can't mix data types. Would a floating point number work? No, it doesn't like that either. But any other number is fine. Right. So what about showing the contents of the list, right? So I think that's kind of where they sort of go next. So this is like the hard-coded approach. In fact, we can copy that in too, but just to play with it. And then let's go through the process of trying to output the contents. So we could try to do it selectively, or we could do it in a loop. And I think a loop kind of makes sense. Let's do a loop. So for int I equals 0, all right, let's do the color ones first, since it's automatically like going to that. And then let's just do a console write line. All right, we'll do that. So maybe for this list up here, oh, I want to do a for loop again. I'm looking for the autocomplete, and it's just not doing it for me. But I'm just following the same pattern here, right? So it's forcing me to type it out. And if I want to run it for the length of my list, which is, all right, count is the thing, right? And then we'll just do kind of the same thing we did here, but we'll change obviously the verbiage. So it's not colors, but it's my list. All right, let's run this and see if it outputs what we think. So this one will output everything that's there, and this one will output everything that's there. Let's try that. All right. Did it work? Yes, it did. All right. So it just proof that we're able to create the list and then output its contents. All right. Well, here's another thing, right? So we talk a lot about this. So let's play with this a little bit. So for each, right? And notice the syntax change. And if you don't like the generic name here, you can always say for each item in my list, right? You could do it like that. And then of course that has to update too. It will automatically traverse. I'll just run it so you see that it works just the same. And what did it throw as an error? Do you guys catch that? Index is out of range, must be non-negative and less than the size of the collection. So this allowed me, and it didn't do it here. Do you notice that? It did it here. So it's not traversing it correctly, right? It's asking me to change my structure. I'm trying to figure out why it's asking me to change my structure. I don't see the why. What is breaking here? I don't see it. All right. Well, for right now, this isn't really critical. but I'm going to switch it back to a regular for loop. All right, which works just fine. All right. I don't know if there's anything else in here we really want to try too much. We tried putting bad info in. We tried, well, we didn't try doing an insert. Why don't we try doing this? All right, so after we've iterated, we'll insert cyan, and then we'll output it again. Right, red, green, pink, red, blue, cyan, green, pink. Right, so it works. The other one that you might want to try is remove at 2, remove blue, and then output the list again. There's the example. And then you notice here at the end, we go red, blue, green, pink, red, blue, cyan, green, pink, red, green, pink. Did this work? Well, okay. So there's a difference between the example and what we did because we already had cyan in there. There's a difference, right? Where the example on the slide didn't have cyan included. So if I would remove the cyan and this and run it, then it looks just like the book, red and pink, right? Blue and green and gone, red and pink remain. All right, folks. I think that's a worthy little example just to play with the lists a little bit. So you get a little bit of a feel for it. Of course, when we get together next week, we'll go through, later in the week, we'll go through the lab exercise and then we'll go through the assignment. You can tell that these are probably going to take a little bit longer. There's like more stuff to do on them. I would like you guys to try them and make sure you do try out the Codios as well. All right, folks, this will cap tonight's lecture. I'll see you all on Thursday.